Now let's see the fundamental concept of permutations and combinations with the help of one simple example. Let's say there are three students named A, B and C, and we want to have a photograph of two students at a time, and we want to know how many such photographs are possible in which there are two students. So now to calculate that number, let's denote the two positions. Now we want to know in how many ways we can fill in these positions. So as we have seen earlier in the examples based on fundamental principle of counting, so this particular position can be filled with any one of the three students, so therefore which can be done in three ways. After having filled that position by one particular student, the next position can be filled with only two ways with the remaining two students. So therefore in all there are 3 into 2, that is nothing but 6 ways of having the photos. So therefore there are 6 photos possible. Now let's consider another situation. We still have the same set of 3 students, but now instead of having a photograph of 2 students, now we want to form a team of 2 students. So now when we say a team, we know inherently that there is no order when we list down the members of a team. So therefore if we see, one of the teams could be say A and B, another team would be say B and C, and the last team would be say C and A, because we know that the team of B and A is same as the team of A and B, because there is no order in listing down the team members. So therefore here we see that there are in all only 3 teams possible, whereas there are total 6 photographs are possible. Now if we see and compare these figures, we know that for every set of 2 people there are 2 possible variety of photos, because they can interchange the position, whereas if we consider the team, it is just one team of 2 students. So therefore the number of teams is half of the number of photographs. So with this, let us go to the formal definition of permutations and combinations. Now as we see here, a permutation is nothing but an arrangement in a definite order of certain number of things which are either different or some of them can be alike, and taken some or all at a time. So it's important to remember that in permutation the order of taking the things is important. Now as far as combination is considered, it is a way of selecting certain number of things where order does not matter. So as we have seen in the example of team, it's a situation where order inherently does not come into picture. So that is the difference between permutation and combination. Now let us see the basic formulae for permutations and combinations. The first formula is for the permutation, which is denoted by NPR, which stands for the number of permutations or arrangements of R objects taken out of N objects. So we are given N objects, out of which we are taking R at a time and arranging them into all the possible orders, and we want to know how many such arrangements are possible. So that is denoted by NPR, and which is given by n factorial upon n minus r, the whole factorial. So it goes without saying that the r has to be less than or equal to n. So therefore if we see a special case, that is if out of n objects we take all the n objects, so that is when r is nothing but n, the left hand side of the formula changes to npn and the right side becomes n factorial upon, now n minus r factorial now becomes n minus n, the whole factorial. So therefore we have n factorial upon n minus n is 0, it is 0 factorial. And we have seen earlier as a special convention that 0 factorial is taken as 1. So therefore finally the answer is n factorial. So therefore nPn is nothing but the n factorial. And now let's see the formula for combination, which is denoted by NCR, which is nothing but number of ways of selecting R objects out of n objects. So it is just the ways of selection, which is n factorial whole upon R factorial into n minus R the whole factorial is n minus R the whole factorial. So as we can see, the NCR is nothing but NPR divided by R factorial. So if you see this particular figure, this is nothing but the NPR divided by R factorial. Now this factor of R factorial comes because in the combination the order is not important, so therefore the number of permutations will get divided by R factorial.